8.7, vocabulary related to algebra and simplifying expressions. An algebraic expression is a collection of numbers, variables, which are letters, operation symbols, and or grouping symbols. Some examples of algebraic expressions are what we see here. It can be numbers like 7, numbers and letters, 7a, 7ab, negative 7ac, 7a squared, 7 times a plus 2b minus c. All of those are examples of algebraic expressions. An algebraic equation is a statement of equality of algebraic expressions. Therefore, an equation must have an equal symbol. So here's an example of an algebraic equation. 7a plus 3 equals negative 5 plus 4a. If we were to separate these and not have that equal symbol, if I had 7a plus 3, that would be an expression. Negative 5 plus 4a, that would be an expression. But once we put that equal symbol in there, that changes it to an equation. So expressions are simplified, which means you perform the operations you see according to order of operations, or PEMDAS. Equations are solved, which means you find out what number the variable should be. We are going to be dealing with algebraic expressions in this chapter. In chapter 9, we will start with equations. So all we're going to be doing is simplifying the algebraic expressions. And in order to simplify an algebraic expression, we need to understand what a term is in algebra. A term is a number, a variable, or the product of a number and a variable. What does product mean? Multiplication. So here are some examples of terms. We have a, 7, 7a, 7ab. Okay, so these are terms. Terms can be products, or terms can be just a variable or a constant, but it can't have a plus or minus in between it. Pluses and minuses separate terms. When a term just consists of a number, it's called a constant. So here are some examples of constants. 7, negative 6, those are constants. When you think about the word constant, what does that mean? It means it doesn't change, right? So the reason that we call numbers constants are because 7 is always going to be 7. Negative 6 is always going to be negative 6. But we call letters variables because they can represent different numbers. So if I had a, like this here, a could represent 0, or a could represent 5. So since it changes, it varies, those are called variables. When a term consists of a variable, then the number connected to the variable by multiplication is called the coefficient. The term 7a has a coefficient of 7. The term negative 5a has a coefficient of negative 5. Those are the numbers in front of the variables. The term a has a coefficient of 1. So anytime we see a variable without a coefficient or without a number written in front of it, it's understood to be 1, because 1a or 1 times a is the same thing as just a, right? Because if I multiply times 1, it doesn't change. The term a over 3 has a coefficient of 1/3. Let me explain that. We just said that if we don't see a number in front of the variable, then it's understood to have a 1 in front. So this would be the same thing as 1a over 3. So we could pull the number in front of the variable. If we pull this in front, then that's 1/3 a. So the coefficient is 1/3. Every variable has a coefficient. If we don't see one, it's understood to be 1. Now, terms with the same variables raised to the same powers are called like terms. For example, 5c and 3c are like terms. 4a squared and negative 8a squared are like terms because they have the same variables raised to the same powers. If variables don't have the same powers, or if they're different variables, then they're unlike terms. 5a and 3b are unlike terms. 5a and 4a squared are unlike terms. Even though they both have a's, one is just an a and one is a squared. So they're unlike terms. So whenever we're trying to simplify terms, we can only add or subtract terms that are alike. So let's do that in these examples. Number 1, 3a plus 5a. When we have like terms, all we do is we add the numbers in front and then the variable stays the same. So we know that 3 plus 5 is 8. And then we put the a back on the end. We're just adding the numbers in front. It's like if we were to say we have 3 apples and we have 5 apples. We put them together, then we have 8 apples. Okay, negative 3a plus a negative 5a. All right, so if I put these two signs that are next to each other together, a positive and a negative is a negative. So that's negative 3a and negative 5a. They have the same sign, so we add them together. We use the sign of the biggest number, so it's a negative 8a. Again, a positive and a negative make a negative, so that's 3a minus 5a. Okay, so this time my signs are different, so I'm going to subtract, use the sign of the biggest number, so it's negative 2a. Number 4, we have negative 3a plus 5a. My signs are different, so I subtract, and I get a 2a. My bigger number is positive, so my answer is positive. Okay, in number 5, let me change these to single signs. Okay, so that's negative 8b squared. Different signs, that's negative. Same signs is positive. Now, are all 3 of these like terms? Yes, they all have b squares on them. So we can just go from left to right. Negative 8b squared and negative 2b squared, that would be a negative 10b squared, plus 9b squared. If I have 10 and I subtract 9, I get 1. It would be a negative 1. But in algebra, if the coefficient is 1, we don't write it. So it's just a negative b squared. Okay, for number 6, again, let me combine any signs that are touching. Okay, so I have 4a minus 2c plus 5. The signs are the same, so that's plus 4a plus 7b minus c minus 1. Now, are all of these like terms? No. So, we're going to combine only the like terms. Here's a term with an a, and here's a term with the a. 4a plus 4a, that's 8a. Okay, let's look for b's. Okay, we only have one term with a b, so we just bring it down. Okay, here is a c, and here's a c. Negative 2c, and this is negative, remember that's understood 1c. So negative 2 and negative 1 would be negative 3c. 5 and negative 1, that would be plus 4. And that's all we can do because these are not like terms, so we have to stop there. And that is simplified.